All right, so we're now moving on to the next section of your book, which is going to be section 4.5. All right, and there's a few things that we're talking about here, and the first one is going to be the fundamental counting rule. So what this is helping us with now is when we're given, before when we were given multiple options like flipping a coin or flipping a coin and rolling a dice or something like that, we had to list out all of our possible solutions that we could get. Or if we're figuring out how many, if we're rolling 2 dice, we had to write out all of our possible solutions and then count them up to see how many total options we have. And now with the fundamental counting rule, we can go through that a little bit quicker to at least find out the total number of options that we have. So what this is saying is in a sequence of n events in which the first one has k possibilities and the second one has k2 possibilities and the third has k3 and so forth, the number of possibilities of the sequence will be just multiplying them all together. So if you think about, in order for us to figure out how many total options we had when we were rolling 2 dice, we had to create that table and we had to go through each one. Right? But if we wanted to just know the total, we could say, well, this dice has 6 total, this dice has 6 total options, so when we multiply them together, we know that we will have 36 total options when we're rolling 2 dice. Now, if we wanted to know all the individual options, we still would have had to write them out. But if we just need to know the total number of how many possibilities we have when rolling 2 dice, we just need to multiply the outcomes of each event. So of the first dice and of the second dice. All right, now this is a coin is tossed and a die is rolled. Find the number of outcomes for the sequence of events. So here we have a coin being tossed, and then here we have a die being rolled. So in order to find the total number of outcomes, we need to figure out, well, how many outcomes do we have when flipping a coin? That's 2. How many outcomes do we have when rolling a die? That's 6. So we just multiply them together. So that means we have 12 total outcomes. All right. There is one more example that we're going to do with this fundamental counting rule, and then we're going to move on to something else. All right, now for this one, we have 4 different options where it's a paint manufacturer who's looking to make several different types of paints. And they can change their paint by color, by type, by texture, and by use. So they want to know how many different kinds of paint can be made if you can select one color, one type, one texture, and one use. Well, for a color, we have 1, 2, 3, 4, 5, 6, 7 options. So we can pick 7 different things from our color. From our type, we can pick 2. From our texture, we can pick 3. And from our use, we can pick 2. So what we need to do then to figure out the total numbers, we need to multiply these 2 together. So 2 times 2 gives me 4. 4 times 3 is 12. 12 times 7 is going to give me 84. So there's 84 different types of paint that we can make based off of these colors, types, textures, and use. All right, now the next thing that we're going to talk about, the next 2 things, is going to be permutations and combinations. All right, the main thing that you need to know for these is that in permutation, order matters. I'll explain that in a second. And in combination, order does not matter. All right, so what I mean by this is if you're running a race and someone finishes first, second, and third, the order matters. If Jane finishes first and Chris finishes second and Steve finishes third, that's the order. If Steve finishes first and then Jane second and Chris third, even though it's the same 3 people, they are not the same because in this case, Jane was first and now she's second. Steve was third, now he's first. So although it's the same 3 people, they do not represent the exact same grouping. So things that you will see that this is affecting is if we're spelling something out or if we're making IDs, so ID numbers, if we're ranking things. But what you can ask yourself is take 3 options, write them down, and then change the order and say, does this mean the same thing? And if it doesn't, then that means that the order matters, and that means you need to use permutations. For combinations, if we're just selecting 3 people from the class, and once again, we're just selecting 3. We're not ranking them in order, but I'm just picking 3 people, and I pick Jane, Chris, and Steve. It doesn't matter if I pick Steve first, Jane second, Chris third, because I'm picking 3. So these 2 actually represent the exact same picking, the exact same group. So I only would need to write it down once because we don't want to duplicate anything. All right, but remember, order does not matter for combinations and order matters for permutations. All right, now let's go ahead and do a couple examples. All right, so the first one that we're going to do is just a basic permutation. And permutations is the arrangement of n objects in a specific order. That's why order matters, because you're arranging them in a specific order. But in this case, when we're just arranging, so if we're given like 10 books and we're arranging all 10, then the formula that we will follow is we will just take 10 factorial. And what factorial means is, if you look up here, 5 factorial is 5 times 4 times 3 times 2 times 1. 9 factorial is 9 times 8 times 7 times 6 times 5, etc. So whenever we are taking factorial, this exclamation point, that's really saying we're multiplying that number and every number underneath of it. All right, let's just do a couple examples for this first to make sense. All right, so we have 5 business locations and we're trying to rank them. So I'm just going to show you how I kind of taught you this before we're learning this permutation. Before I told you should write out dashes for all of your events that are taking place. So here we have 5 locations that we're picking, that we're ranking, so we have 5 dashes. In our first event, we have all 5 of the locations we can use, because there's 5 locations, we haven't ranked them yet. So we would have 5 that we can pick here. Our second event, once we rank our first one, then we no longer have that location left over, so it's gone from us. But now we have 4 that we can left over that we can rank. And then after we pick 2, we're down to 3, we're down to 2, and we're down to 1. When we have these multiple events that are taking place, we need to multiply them together. All right, so that means if we multiply them, we would get 120 ways that we can rank these. All right, and it's perfectly fine if you do this. It's going to take you longer to solve a problem, especially if this is saying instead of 5, it's 15. But what you need to be able to identify is saying, all right, we're ranking our businesses. So that means order matters. So that means we need to take a permutation. And then we're going to learn in the very next question, or in a couple questions, are we ranking all of them or are we only ranking part of them? If we're ranking all of them, then it's simple. We just do our 5 factorial, which in this case, we have 5 locations. We're ranking all 5. So we are ranking all 5. You can type 5 factorial into your calculator and it will give you 120. So that means there's 120 ways. So you need to be asking yourselves 2 things. 1, especially when it's a permutation. So does order matter? If it's yes, then you're asking yourself, am I ranking all of them or am I ranking just some of them? And if we're ranking all of them, it's just simply 5 factorial. There's 5 locations, we're ranking 5. If we're only ranking part of them, there's a different formula that we need to use. All right, so for this, it says, suppose the business owner, an example, the one that we just did, wishes to rank only 3 of the 5 locations. How many different ways can she rank them? All right, so in this case, we're not ranking all of them, and I'm going to show you how you could do this based on what we were doing prior before we're going to learn this formula. We're now only ranking 3 of them. Well, when we're ranking 3 of them, we have 5 businesses in the first part. We have 4 after we rank one of them. Then we have 3 after we rank 2 of them, and we're stopping there because we're not ranking our 4th and 5th. So we would just multiply these together, which would then be equal to 60. So there's 60 ways we can rank these. All right, but when you're only ranking part of them, there is a specific formula that you can follow. And I'm going to erase this, and we're going to go over the formula now. All right, but it's perfectly fine if you want to do it that way. You still get the right answer, but just remember, if there's 20 and you're ranking 17 and 20, it's going to take you a while to write all of them out. So that's why it's not efficient. But if you look, if you're ranking part of them, and you take your n factorial, that is the total number that you're ranking, or the total number of businesses that you have, and then you subtract how many you're ranking from it. So your R is how many we're ranking. So our N in this case is all of our businesses, which is 5. So it's 5 factorial. And our R is going to be 3 because we're ranking 3 of them. So it's 5 minus 3 factorial. So this is then equal to 5 factorial over top of 2 factorial. And if you want to do this by hand, you can then write out 5 times 4 times 3 times. Once you get to the factorial in the denominator, you can stop because they will just cancel each other out. And 5 times 4 times 3 is equal to 60. Right? Or you can use your calculator. And I went over this, or I'm going to go over this in class, or I went over this in class. But you would do your first, you pick however many you have, so it's 5, and then you do NPR, and then you choose how many you're selecting, 3. And this will give you your answer. And if you don't know how to find it on the calculator, just ask me. I'll show you how to find it. All right. Now the next one that we're going to go through, but we're going to go through the formula first before we go through a problem, is combination. And remember, combination is where order does not matter. So it does not matter who is selected first, second, etc. And what we do here is the total number of objects we have. It's our n factorial. And then we will do our n minus r, so however many we're picking out of that n, and then we multiply it by our r factorial. Right? So this is the formula that you will use, or you can plug it into your calculator as n, and then you'll press the NCR, and then you press the number that's r. So let's just go ahead and do a couple examples with this. All right, before we do an example though, I do want to go through and show you the difference between a permutation and a combination. Here it says, a television news director wishes to use 3 stories on an evening show. One story will be lead, second, and a closing story. If there's 8 total stories to choose from, how many possible ways can a program be set up? Well, since our programs are being denoted as a lead story or a second story or a last story, and the lead story is not the same as the second, and the second is not the same as the last, that this means order matters. So that means we will need to use our permutation. Where here it just says a newspaper editor has received 8 books to review. He decides that he can use 3 reviews in his newspaper. How many different ways can the 3 reviews be selected? He doesn't say he's ordering them in any way. He's just picking 3 of them and putting them in his newspaper. So in this one, order does not matter. So it will be a combination. All right, we're not going to do the top problem, but we're just going to do this bottom one. So since it's a combination, we can do n factorial over top of n minus r factorial times our r factorial. And here we have 8 books to review. We're picking 3 of them. So it'll be 8 factorial over top of 8 minus 3 factorial times 3 factorial. So this 8 can be broken down to 8 times 7 times 6 times 5 factorial. I'm stopping here because since this will give me a 5 factorial, I know it's going to cancel out right there. So we can stop at our higher of the 2 factorials in our denominator. And then I'm going to write out this 3 factorials, 3 times 2 times 1. This 5 factorial cancels out here. This 3 will reduce this 6 to a 2. And this 2 will reduce this 8 to a 4. So 2 times 4 is 8. 8 times 7 is 56. So there's 56 ways. Or we can just use our calculator. We can then do 8 NCR. If you're not sure where to find that, it's in your stats. If you have a graphing calculator, or it's one of the buttons either near your divider or your multiplication if you are using just a regular scientific calculator. And you would do 8 NCR3, and it will give you this answer in return. All right, now this is the last question we're going to do. In a club, there are 7 women and 5 men. A committee of 3 women and 2 men is to be chosen. How many different possibilities are there? So we're not ranking the women or the men. We're just selecting them. We're not picking them to be any specific role, like a secretary or treasurer or president or anything like that. We're just picking them. So in this case, order does not matter, so it's going to be a combination. And if you notice, we have women, 7, and we're picking 3 of them. We have men, and we're picking 2 of them. So that means here we actually have 2 different cases. I'm going to just use our calculator for this one. So we have 7 total women, and we're doing a combination, and we're choosing 3 of them. So when we do 7 NCR3, that gives us 35 different combinations we can make. And then here we would have 5 men, and we're choosing 3 of them. Or I'm sorry, choosing 2 of them. So then it will be 5 NCR2, and that gives us 10 combinations. So we can pick a total of 35 different combinations for women and a total of 10 different combinations for men. And as we learned earlier in this section, in this video, about the fundamental counting, when we have different events taking place, we can find the total number of them by multiplying. So that means there are 350 different possibilities of picking 3 women of the 7 and 2 men of the 5. All right, that is it for this video, and that's it for this section.